21A, number 2. In a certain city, there are 100,000 persons from 18 to 24. A simple random sample of 500 is drawn, of whom 194 turn out to be currently enrolled in college. Estimate the percentage of all people in the city who are currently enrolled in college. So the first step in this problem is finding the SD of the box. Well, or sorry, these are options, right? That's not the first step. The first step would be 3, writing down the box model. So what's in the box? Well, we don't know. That's the whole point. So we do a survey. 194 out of 500 is 38.8%. Now, we're going to assume that that is correct, or at least that's as close as we can get. If we have done our survey correctly, followed all the rules, simple random sample, we end up with this percentage. The best we can do is say, hey, 38.8%, that's what we have. So I am going to stick these numbers in the box, 0.388 ones and 0.612 zeros. Okay, so this is my expected value, plus or minus my standard error. Well, I can't get the true standard error, so I'm just going to make it up using the numbers that are in the box. So I take the square root of 0.388 times 0.612. And it's going to be something close to 0.5. So my standard deviation is 0.487. And I made 500 draws. So I need the standard error for percentage. And we use the shortcut by just dividing it by the square root of 500. And notice I haven't rounded anything yet. And now I get here and I'm going to say 2.18. So, estimate the percentage. Well, I think there are 38.8%, give or take 2.18%. Okay. Now, that leaves me with a 68% confidence. I probably want to change that in the future, but we've only talked about doing it. We've never actually done that. Okay. So I am 68% confident that the true percentage is somewhere in this window. And we actually want probably a 95% confidence level, but we'll get to that a little bit later. Any questions about that? This is statistics. We are making an inference on the population given a sample. All right, number 3. In a simple random sample of 100 graduates from a certain college, 48 were earning 50,000. Oh, sorry. Are earning 50,000 a year or more. Estimate the percentage of all graduates of that college earning 50,000 a year or more. So, in my box, I have 48% and 52%. And I'm not even going to bother with 1 and 0. 48% is yes, 52% is no. So my expected percentage is 48 plus or minus the standard error. And the standard error is simply the square root of 0.48 times 0.52 divided by the square root of the number of draws, which is 10. So the square root of 0.48 times 0.52, we divide that by 10, and I get 5%. Now, do you guys recognize the beauty of that? Do you remember how hard that used to be? And now we are creating numbers that we don't even know are correct. And the mathematics has become so simple that we can solve this problem in less than a minute. So I'm 68% sure that the true percentage is 48, give or take 5%. Now, why is this number so much larger than the last one? In the last problem, we were more accurate than 5% because I only talked to 100 people. The more people you talk to, the smaller the standard error is going to be. Well, how much smaller? Well, the standard error is calculated, the standard error of percentage is simply the SD divided by the square root of the number of draws. So the more draws we make, the smaller our standard error is going to be. And if we sample everybody, then the standard error is 0. Because there is no error. If you talk to everybody, then you have created a parameter. All right. Number 4. A simple random sample of size 400 was taken from the population of all manufacturing establishments in a certain state. 11 establishments in the sample had 100 employees or more. Estimate the percentage of manufacturing establishments with 100 employees or more. So 11 divided by 400 is 2.75%. So in the box, I put 0.275 and subtract that from 1, and I get 97 or 0.9725. So my expected value is 2.75 plus or minus the square root of both of those numbers divided by 20, which is the square root of 400. So the square root of this times this, and then I divide that by 20, and I end up with 0.82%. That's the square root of 400. So I divided by the square root of 400. That's the number of draws. Okay. Why is this number so small? More people, right? In the previous problem, I talked to 100. Now I talked to 400. Is that enough? Well, it also, these numbers also create the standard error. So if I look at the standard deviation, I get 0.16. So standard deviation is 0.16. That is a pretty small standard deviation for a 0-1 box. What is the biggest standard deviation that a 0-1 box can create? If 50%, or it's not 50%, it's 0.5, right? So the most spread out a 0-1 box can be is this. And the standard deviation there is 0.5. It cannot get it spread out any more than that, right? The average is 1/2, and the average distance from the average is also 1/2. So the reason that this number is so small is these numbers are not close to each other, which creates a small standard deviation. And then when I divide that by a larger number of draws, then this number is pretty small. So your error depends on two things. How close are your two percentages, which creates your SD? If your percentages are not at all close, then your standard error is going to be smaller. And how many draws did you do? The more draws you make, the smaller your standard error will be. Okay? And none of that has anything to do with the size of the population. We don't care. As long as our sample size is not close to the size of the population, we simply don't care. Okay. Did I answer everything there? Number 7. Okay. Suppose there is a box of 100,000 tickets, each marked 0 or 1. Suppose that, in fact, 20% of the tickets in the box are 1. calculate the standard error for the percentage of ones in 400 draws from the box. So in this case, I do know that the answers are 0.2 and 0.8. What will happen when I do 400 draws? Well, I expect 20% plus or minus the square root of 0.2 times 0.8 divided by the square root of 400. So square root of 0.2 times 0.8 divided by 400. Nope. Divided by 20. 2%. What does this mean? Interpret this. You're 68% of the people who play this game, who do surveys, will get 20%, give or take 2%. Okay? So this is saying 68% will get 20 plus or minus 2. Okay? Now, what if I change it and I don't know what's in the box? And I do a survey and I get 0.2, is this going to change? No. But the meaning changes. So what is the meaning if I do a survey and get 20%? I am 68% sure that the box is 20% plus or minus 2%. Okay? Same calculations, but different meaning. Okay? Now, we are lying to you a little bit, but that's okay. We're not going to worry about the lie right now. Okay. Well done.